All right, guys, here's my next video. This should help you with problem number 5 on the assignment this week when you're doing your module 4 assessment problems. Okay, so my sample 5 problem states this. Stan operates a lawn service company and has 150 customers. He has some customers who pay $20 per week just to have their lawn mowed. The rest of his customers pay $30 per week to get their lawn mowed and their shrubs trimmed. Stan earns a total of $4,000 per week in total income from all of his customers. How many customers just get their lawn mowed, and how many customers get their lawn mowed and their shrubs trimmed? So they're asking us to find out of how many of the 150 customers just get the lawn mowed and how many of his 150 customers get the lawn mowed and trimmed. So there's two things we have to find out here. So we want to let our X variable represent one piece of information and our Y variable represent the other piece of information. So you can see here I'm letting X represent my lawns mowed and Y represents my lawns mowed and bushes trimmed. And I'm going to highlight that here for you. Okay, so then we can create our two equations to form our system. So I know he has 150 customers, so I can let my customers who have their lawn mowed, which is X, and my customers that get the lawn mowed and the bushes trimmed, Y, equal the 150. So there's my one equation. My second equation is going to involve the money that the customers spend on getting their lawns serviced by Stan. So the first part of the equation, the 20x, is the $20 that they pay just to get the lawn mowed. Then the 30y is the $30 those customers pay to get the lawns mowed and the bushes trimmed. And then that's going to yield the amount of money that Stan makes during the week, which is $4,000. So on a system, then we have three methods we could use to solve the system. One method is graphing, which is the most cumbersome and probably the least reliable method because sometimes it's difficult to see where the two lines will intersect. So the preferred method for solving is either substitution or elimination. Those are both good methods. I'm going to demonstrate the elimination method first, and then if my video is not getting too long, I'll try to show you the substitution method. So for the elimination method, we're looking to add these equations together with the hopes of either getting the X variable to cancel out or the Y variable to cancel out. For that to happen, we have to have numbers for the coefficients that are opposites. So that would mean that on that first equation, I need to have either a negative 20x or a negative 30y. So I need to change that first equation. I'm going to change it by multiplying the whole equation by negative 20, and that will give me my negative 20x. So it's going to look like this. I'm going to put parentheses around the whole equation. I'm going to put a negative 20 on the outside of the parentheses. Then I'm going to show you with arrows, just like I did in class. I'm going to take negative 20 times x. That's going to give me my negative 20x. Then I'm going to take negative 20 times the y, and that's going to give me my negative 20y. I'm going to write my equal sign. And then I'm going to take negative 20 times the 150, and that's going to give me negative 3,000. Now, I'm going to draw my line here, just like I'm doing an addition problem. I'm going to put a plus sign here. And now when I add these equations together, you can see that on the X variables, the coefficients are opposites. So opposites combine to give me 0, so that eliminates that variable. So now my Y's, 30y plus a negative 20y is 10y. And I write my equal sign, and 4,000 minus 3,000 is 1,000. Now I'm going to rewrite this here, and I'm going to solve this for you for y. So 10y means 10 times y. So to solve that, we're going to use the inverse operation, which is division. So I'm going to divide by the coefficient here, 10. And I have to do the same operation to the right side of the equation. So I'm dividing that by 10. 10 divided by 10 is 1. 1 times y is y. 1,000 divided by 10 is 100. So y is equal to 100. Now, I can go back to my original equation, the x plus the y equal the 150, and I can replace my y variable with 100 now, and that will allow me to solve for x. So I'll have x plus 100 equals 150. And now to get x by itself, I'm going to get rid of that 100. The inverse operation here is subtraction. So I subtract 100 here, and I need to subtract 100 to the other side of the equation. The hundreds are eliminated. You bring down your x. 150 minus 100 is 50. So my x is 50. My y is 100. Now what does that represent? Remember up here, x was lawns mowed. So we know now that he has 50 yards that just get mowed. And then he has 100 yards that are mowed and bushes trimmed. Okay, so that's the elimination method. All right, I'm going to quickly try to show you the substitution method so you have both methods and you can pick the one that's easiest for you. All right, so here we go with substitution. I'm going to just quickly rewrite those two equations. The first one was x plus y equal 150. The second one was the 20x plus the 30y equal to the 4,000. So if I want to use substitution, then I either have to get x equal to something or y equal to something. So on this first equation, I can get x equal to something by eliminating this y variable. To do that, I subtract y to both sides of the equation. So then x will equal 150 minus y. So now I can use this and I can substitute the 150 minus y into the second equation here for x. So I can have 20 times 150 minus y plus 30y equal 4,000. So now you have to use your distributive property and take 20 times the 150, which is 3,000. And then you take 20 times that negative y, which is negative 20y. You bring down that plus 30y equal to the 4,000. All right, now you can see all that. Sorry about that. All right, now, when I saw this equation, I'm combining like terms. So I recopied the 3,000, and then this y term and this y term can be put together. Negative 20 plus 30 is positive 10y equal the 4,000. Now I'm going to solve for y, so I have to isolate it and get rid of this 3,000. The opposite of that is minus 3,000. And then we have minus 3,000. Remember how we have to do the same operation on both sides of the equation. So 3,000 is eliminated. I bring down the 10y. On this side, 4,000 minus 3,000 is 1,000. Now I'm down to 10y equals 1,000, which is what I had on the elimination method. So to solve this, I'm going to divide by 10. So y is 100, and you can kind of tell, right? I get the same solution. And then to find x, I'm going to sub it back into that original equation. X plus y is 150. So I'd have x plus 100 is 150, and then you can see minus 100 to both sides, just like I did earlier, and x is 50. So 50 yards are just mowed, and 100 yards are mowed, and the bushes are trimmed, which is the answer we got originally. So when you do your problem number 5, you can use either the elimination method or the substitution method to solve whichever one you think is easiest. You do not need to demonstrate it both ways for me. I only did that for you so you could see that there are choices, and you should pick the method that you think is easiest. Hope this helps. Talk to you later.